Welcome to the third episode of Migrate AWS Lambda to Azure Functions. In this episode, we're going to take the prime code, migrate it to the function app we just created, as well as implement the cache. Let's get started. Let's go ahead and add our isItAPrime function. I'm going to click Create New, and again I'm going to go with the HTTP trigger, only this time I'm going to name it isItAPrime. We'll keep the access anonymous for now and click Create. Now this will give me the same boilerplate as before, but it's a starting point that I can use to modify the code. Now that this is created, I'm going to take a few simple steps. First, I'm going to paste in our method to compute the prime. Next, I'm going to paste a little helper function for closing the context. I'm going to take this async off and just use an approach that calls context done, because later we're going to introduce a library with some promises in it. So we'll take this out. We'll replace this with some logic that looks for the prime number and gets prime test ready to go. And notice that I'm using, instead of a console log, a context log. This will ensure that all of this information is written out to the log files. After we've established that it's a decent number, we'll make a call to isDone, which takes the number we're passing, whether or not it's a prime. So I'm going to go ahead and call the isItAPrime method, and then whether or not it's cached, which right now it is not cached. Otherwise, if we're not past the prime, we want to provide a helpful error message. So we'll paste this in. Prime was not passed. We can save this, go to our test, and if we run the existing test, you can see it tells us to pass a prime. Let's go ahead and pass a prime number. And that successfully processes true. And we'll go ahead and pass it a non-prime number. And that evaluated to false. If we take a very big prime, you'll notice we have a similar issue, that the computation takes a little bit longer. So we have a bit of a delay as it's figuring out whether or not it's a prime, and eventually it comes back and says it's true. The final step I want to take is to implement caching. And to do that, I'm going to use a special library called Azure Storage that will allow me to interact with a storage account that was already created for me. What I want to do is open up the console, and this will place me inside the directory for the function. I'm going to move up one level so that I'm at the function app level. I'm going to go ahead and initialize a package.json file. This is a node project, so I can use this package.json to add dependencies. Now that I have this file created and we can list it and show that it exists, I'm going to use npm install, save it to the file, and the package I'm looking for is called Azure Storage. Now it's been installed, so I can start adding code. I'm going to navigate to the top, and to make this available everywhere, I'm pulling in the Azure Storage. When my function was created, Azure automatically set a secret in my environment to connect to the storage account that's associated with this. So I'm just pulling this from the environment. If I wanted to use a different storage account, I could simply add a different secret or connection string and access that. This is creating a table service. Storage contains a special service called table storage, which will be perfect for our cache. This is just a helper for adding items to the cache, and this is the name of our table, which is primes, which is the same name we used in our Lambda function. Now I have my package in place, it's time to implement the code for the cache. Instead of simply completing the function here with the prime, I'm going to paste this code in. Let's take a quick look at what it does. First, it tries to retrieve a value from the cache. This is using a key of the prime number itself, and when that promise returns, it's looking to see if there's any error. If there's an error besides a not found error, it's just going to indicate that it wasn't able to access the cache and go ahead and evaluate the result. If there's only a 404 error, that simply means the item's not in the cache. Therefore, we'll go ahead and compute the prime. We'll create this entity to insert in the cache. And this just has a partition key, which we hardcode to key, a row key, which is a unique key, which is the prime number, and the value is prime. And then we insert that. If there's an error, we go ahead and log the error. Otherwise, we note the success. And either way, we return the result of whether or not it's a prime. Back up here, if there was an error, we jumped into this piece of code. If there wasn't an error, it means it successfully retrieved it from the cache. So we log that it was found in cache, and we evaluate that value from the cache and return that to the method. Let's go ahead and save this. We'll open up our logs and we'll test this with a large prime number. So I'm going to go ahead and run this test. And as you can see, it executed and added it to the cache. Let's go ahead and run it again. As you can see, it retrieved the item from the cache and ran faster. Now we've successfully migrated our code to Azure Functions. In the next episode, we're going to take a deeper look at concepts in Azure Functions, such as resource groups, how storage works, etc. Stay tuned for that. In the meantime, you can learn more about the storage we use to implement the cache at aka.ms/about storage.